5 years ago, who could have accurately predicted that we would be stuck at home right now? Or at least severely limited in our ability to go to work or to socialize. The separate events leading up to this seemed pretty insignificant on their own, but together led to a large event with quite overwhelming consequences. We could ask the same question right now. Where will we be in 5 years, and what seemingly insignificant things will lead to the reality we will be finding ourselves in?
There is beyond the full of light, beyond the reach of dark. What was await us? And yet we see things insatiably. Such is our faith.
Now, some of you might argue that there are models with which we can predict the behavior of events like this, which there is some truth to that, although while there are measurable properties that can be used to construct a model, it cannot always be used to accurately predict over long time periods because of one thing: chaos. Maybe you've seen chaos as this. Or for those from the Sonic fandom, like this, or these. This, and probably this as well, but we don't talk about that here. Or maybe you've heard a certain psychologist talk about it. And finally there's this. Hey, wait, did Warhammer just... anyway. Both as a word and as a concept, chaos has a long and interesting history, which quite interestingly affects our modern ideas of it, sometimes in ways that aren't entirely obvious. Let's have a look at that history. Chaos originally was a Presocratic concept within Greco-Roman traditions. As described by Hesiod's account, it is a concept of cosmogony, which describes how out of the primordial state of the universe, the earth and the sky were separated. Chaos being the first thing to come into being, and then the primordial deities, Gaia, the goddess of earth, Eros, the goddess of love and procreation, and Tartaros, which in its own is considered both a deity and a void-like place. In some interpretations, chaos has also been described as a void, either above or below the earth. Nyx, goddess of the night, and Erebos, a personification of darkness and husband of Nyx. Both are also seen as primordial deities in some traditions. Later, as philosophers like Plato and Aristotle started investigating space in a physical context, working on the idea that chaos was something that existed independently of physical matter, chaos was lifted out of the mythological context and put into a philosophical one. Fast forward to the 5th century, the idea of the first matter, or prima materia, started to take shape, which led to the conflation with primordial mud, but that did lead to the modern idea of chaos to some extent, which we'll get to in a moment. What was seen by some as void was seen by others as water, which I guess explains the big drip, maybe? Both of which describe the concept of Theoi, or the Great Deep. At this point, conceptions of chaos from other religions like Christianity were thrown into the mix, and the pursuit of the aforementioned prima materia gave rise to alchemy and later in the 1970s chaos magic. Which is pretty interesting, but apart from the name, it doesn't actually have anything to do with chaos. An attempt is made to make a connection with consciousness, but chaos magic does not actually have anything to do with the concept of chaos. To be completely honest, I didn't actually catch this before I started looking into the topic. I just added the chaos cross to the collection of things to put on screen, only to find out later on that there's not much of relevancy here. Anyway, as far as the religious context goes, nowadays it's generally viewed as the state of the universe before any kind of creation event. Now, the idea of chaos in regards to chemistry, physics and mathematics does have a few branches that stem from the concept talked about earlier. During the Renaissance there was a new interest for classical literature, Ovid in this case. YouTube, please don't take down this video. The author thought of chaos not as a void but rather a formless, disorganized mess, from which the idea of chaos being disorganized or being without order comes from. Another quite interesting thing to come from this is the etymology of the word gas. Jan Baptist van Helmont, a Belgian philosopher and chemist, came up with the term after he found out that either the reactants or the products of certain reactions turned out to be neither solid nor liquid. Before we move on to the next part, there's something I really need to address. There seems to be a negative connotation when it comes to chaos. When you look at the definition, it is described as being a state of disorder, which, while it is the opposite of order, it is not randomness. Randomness does not follow any kind of rules. Well, yeah, other than that it doesn't follow any kind of rules. Whereas chaos can most definitely have clearly defined rules. Which gets us what I'm going to talk about now, which is deterministic chaos and chaos theory. So, what does deterministic chaos mean? At first sight, the term seems self-contradictory, but let's look into how both parts of the term are defined. Determinism in this context means that consecutive states of an object in a system, particles for example, are causally linked. This simply means that the path a particle takes is determined by things that happened to it in the past. In such a system, the trajectory of particles could be defined as an equation, especially in controlled and simulated environments, which would mean that at the beginning of the process all states of all the particles in the system as a whole have already been determined before it even starts. But how could such a system be chaotic? The figure that has been on screen for the last minute or so, known as the Lorentz attractor, is a good example of a chaotic system. The path the dots that are moving across the screen take is determined by a set of equations that were initially derived by Edward Lorenz from a model used to predict the weather. He found that when even the tiniest change was made to the initial conditions of the system, the outcome would be completely different. In this case, the initial angle at which the dots are moving is the same, but the location is changed by a tiny amount. At first this isn't visible, but as time goes on the gap between them becomes larger and larger, and at some point the particles split up and move to different wings, as it were, of the shape. The wings are simply the trajectories of particles being traced out, and you can see that particles tend to move around two fixed points in this case. These points are called attractors. The shape of the Lorentz attractor is what eventually led to the name of the butterfly effect. Now, there is another definition of the butterfly effect. A butterfly flapping its wings in Brazil can cause a hurricane in the US 2 weeks later, which in a sense describes the effect, but not necessarily in a way I particularly like. But from this we can say that the first property of a chaotic system is that it has to be sensitive to initial conditions. Another property the system needs to have is what's called a dense collection of points with a periodic orbit. Now, this one is a little bit more complicated. When you hear the word orbit, you might think of that as something cyclical or repeating, but in the case of chaotic systems, this does not have to be the case. In this context, all it means is that a set of points needs to move through the system around a specific point within that system, that point being called the attractor. Now, this isn't to say that there are no looping parameters when it comes to the property of high density of periodic orbits. All that means is that you can pick any point in the attractor and a distance from it, and there will be a periodic orbit between those points. Lastly, chaotic systems have a property called topological mixing, which is a fancy way of saying that multiple sets of points can end up being mixed into each other and are then pretty much inseparable. You can kind of see that as adding milk to your tea. And yes, I add milk to my tea. I'm not getting into that discussion right now. Look up ISO 30103 if you really want to know why I do that. This is also to say that the process can usually only happen in one direction on its own. These properties make it very difficult to make accurate predictions, especially over long time periods and even in a deterministic system. In short, even small inaccuracies in measurements can greatly be magnified over long time periods, making the results that come from it inaccurate. Another thing is that the behavior of one part of the system might not necessarily match that of the entire system or another specific part of it. To get an accurate picture of the entire system, you would need to analyze it entirely, which practically isn't very convenient. This leaves you with a bit of a dilemma. You either spend a lot of time taking samples and analyzing them and base your model on that to get relatively accurate results, or you take less time and the system ends up being less accurate. This gets us to how things like the weather, epidemics and pandemics are difficult to predict and model, especially over long time periods. Right now, this is especially noticeable when it comes to the number of reported cases, which unfortunately lags behind the actual number of cases. This doesn't make the situation absolutely hopeless. It doesn't take away our ability to make predictions, but we just need to keep in mind that they are just predictions. And there are obviously more practical ways of dealing with this. Masks are a good example, but social distancing is a really good one as well. As shown in this simulation, by temporarily limiting the mobility of those who have been tested, the spread can be reduced by a lot. So that is about it when it comes to defining chaos. There's a lot more I could talk about, but I'll cover that in more videos in the future. When that will be, I currently cannot tell you. Special thanks to Comrade for proofreading the part of my script about the Greek and Roman interpretations of chaos. That was honestly something I didn't know a lot about and I didn't want to misrepresent it, which the same goes for the rest of the video. I did my best to ensure the information in this video is correct. In case you've got any questions or corrections or maybe tips in general, please let me know in the comments. Sources are in the description, so you can check those out too. If you enjoyed this video, make sure to like and share it around. If you want to see more of this, hit the subscribe button and hit the bell. Branch out into the unknown. You might find something interesting.